Hi, geometry students. We're going to look a little bit more at 3D shapes today, but what I want to get into today is how to find the surface area of some 3D shapes. And we're going to do a couple of them today, we'll do a couple of them later on, but the two we're going to focus on today are prisms and cylinders. Now, before we get into this, we need to talk a little bit about what surface area is. Surface area is how much it takes to cover the outside of a 3D object. We're not talking about how much it takes to fill a 3D object. That's volume. That's a completely different idea. Surface area is how much does it take to cover the outside of it. And when we measure surface area then, our units are always going to be square units. How many like 1 by 1 squares would it take to cover the entire outside of that shape, whatever that shape is? So the first one we're going to look at is a prism, and we're going to be looking at more specifically right prisms. Now, if you have a right prism, here's what you have going on. You have two congruent opposite faces connected by rectangles. Now, these congruent opposite faces are going to be what we call the basis. These could be different shapes. You could have what we call a triangular prism, where the opposite faces are triangles, a rectangular prism where the opposite faces are rectangles. We could have like a hexagonal prism where the opposite angles are hexagons. It could be a lot of different things for the bases, but they have to be congruent opposite faces for the bases, and it has to be rectangles connecting those. So how do we find the surface area of one of these? Well, to do this, we've got a formula here, but I have it broken down into pieces. So we have 2 times capital B plus capital P times H. Capital B stands for area of the base. This is the thing that a lot of people mess up on this. This is not a length. This is an area. Capital B stands for the area of the base. Plus the perimeter of the base, that's what capital P stands for, times the height. Now I have the height defined here as the distance between the bases. Height doesn't have to go up and down in a prism. If you took that prism and set it on its side, the height could actually be a horizontal length. So it's just the distance between the two bases. Now that's a formula that will always work. Another option, if you don't like that formula, or if you just don't like formulas real well, is add up the area of all the faces. So you could just take your whole shape, find all the faces put together, and so there could be like 5, 6, 7 faces, it just depends on what shape the base is basically, and add up the area of all those faces put together. So let's see if we can put this to use on this one. And I kind of made this one a little bit tricky because we're going to have to think about what shape the bases are. Common mistake is look at the bottom and say base. That is not the case always. The bottom of this is a rectangle. That is not the base. Now look over here. For our right prism, the two congruent opposite faces are the bases. In this particular one, the two congruent opposite faces are that triangle and this triangle, which means this has triangles for the bases. And the name of this shape, I'm going to put this up here, is a triangular prism. When you name a prism, you always name a prism by what shape the bases are. And so this is a triangular prism. So I'm going to use this right here and see if we can find the surface area of this. And so first off, we've got to find capital B. Now capital B stands for area of the base. And I'll tell you what, I'm just going to figure this out right over here. The base in this we just found out are triangles. So the bases are these two triangles. They have the exact same area, so it doesn't really matter which one you find the area of. I'm going to do the front one here just because we have more information on it. Now, quick reminder, the area of a triangle is 1/2 times base times height. So in this triangle, we're kind of ignoring the rest of the shape right now. In this triangle, the base of the triangle is 6. The height of the triangle is 5. And so the area of this triangle is 1/2 times 6 times 5. All right, and so the area of this triangle then would be 6 times 5 is 30. And so we've got 30 times 1/2, which means we've got 15 for the area of the base. All right, so now let's see if we can put all this in here and figure out the surface area of this thing. So we've got surface area is 2 times area of the base. We just found out the area of the base is 15, plus the perimeter of the base. Perimeter, remember, means add up the distance around the outside. And it's perimeter of the base, which means it's the perimeter of this triangle right here. So perimeter is just distance around the outside. This 5 is irrelevant in that. So we've got 8 and 6, and then we've got this length, which isn't labeled here, but back here it's labeled as 4. And so our lengths on this triangle are 8, 6, and 4. And so 8 plus 6 is 14, plus another 4, that's 18. So the perimeter of the base is 18 times the height of the prism. Now this is where this is important. Common mistake here is just say height is 5. That's the height of the triangle. The height of the prism is the distance between the two bases. So how far is it from this triangle to this triangle? That's 12 units, therefore that's the height of this prism. All right, everyone okay with all that so far? So now we just need to do a little bit of math here and figure out what we get when we add all this together. And so this part's 30, and then 18 times 12, that part right there is 216. And so this means we've got 30 plus 216, and so in other words, we've got 246 is our surface area. Now, for the units on here, remember we're talking area, and so these were all measured in inches. So this is 246 square inches. And you can write it like that, and I know I've said this before this year, but when you say it, you shouldn't really say inches squared, you should say square inches. Just because in industry, that's the way it's said. If you go buy carpet and say I need, 300 feet squared of carpet, they're going to say, do you mean square feet? Because that's how it's really talked about. So there's the surface area of that triangular prism. Now this shape here, I just wanted to look at this for a second. We're not actually going to find the surface area of this. I just wanted to look at this and think about which sides here, which faces are the bases. Now this one is what we would call a rectangular prism. Do you notice all the shapes are rectangles? Which means we're supposed to have two congruent opposite faces connected by rectangles. Well, it actually doesn't matter what pair of opposite faces we use for the bases. We could use the top and bottom, and I have a feeling that's what most people would do here, and that would work fine. Or we could use the front and back, or we could use this side and this side as the bases, and it would all be fine. And so a rectangular prism is kind of an oddball, where it doesn't have specific pair of opposite faces that you have to use for the basis, because it's all rectangles, and so it's all connected by rectangles anyway. All right, so I just wanted to mention that. Now, would we have had to use this formula to solve this? No. If you'd rather find the area of this triangle, and then say this triangle is the same, so you'd have like 15 plus 15, plus the area of this rectangle on the bottom, which would be 12 times 6, plus the area of this rectangle on this side, which would be 4 times 12, plus the area of this rectangle on that far side right there, which would be 12 times 8, and then add all those answers together, that would be just fine, and you'd still get 246 square inches for that. All right, is that making sense how we're getting that so far? So the other topic that I wanted to discuss just slightly today is a little bit with cylinders. And so we're going to see this is actually really similar to what we just did. So if we look at a cylinder, the definition of a cylinder, first off, is a solid with parallel circles for the bases. And so you have one circle, another circle, and then like this curved surface connecting those two. So the surface area formula for a cylinder could be written this way. 2 times capital B, remember capital B is area of the base, plus CH. This is actually the exact same formula as a prism. I changed the P to a C. The reason is, if we find the distance around the outside of a polygon, we call it perimeter. If we find the distance around the outside of a circle, we call that circumference instead. But they're both the distance around the outside of the shape. And so this is actually the exact same formula that we just had for a prism. However, we can be more specific with a cylinder. Because a prism, the bases could be a lot of different shapes. We could have a triangle, a rectangle, a hexagon, a pentagon, any polygon basically could be the base of that prism. For a cylinder, the bases are always the same shape. They're circles. Now, that being the case, we could simplify this formula a little bit, or I guess make it more specific for just cylinders. Because if the base is a circle, the way we find the area of a circle is pi times radius squared. And so the area of the base part becomes pi r squared. The way we find circumference of a circle is pi times diameter or 2 pi r. Both of those say the same thing. And so just because it gives it a little more nice symmetry in here, instead of saying pi times d, I'm going to say 2 pi r. And so that is the circumference, and then we still have the height on the end here. So there is a more specific formula for the surface area of a cylinder, 2 times pi times radius squared plus 2 times pi times radius times height. So let's see if we can put this to use on this particular cylinder I have drawn over here. So we've got a cylinder here where the radius is 10 inches, the height is 14 inches. Now again, height doesn't have to go up and down. If I just took this whole cylinder and set it on its side, then the height would actually be a horizontal distance. So let's see if we can find the surface area here. So we've got surface area is 2 times pi times radius, which is 10, squared, plus 2 times pi times radius, which is 10, times height, which is 14. And so there's our formula with everything plugged in where it needs to go for surface area, and we've just got to do some computations here. Now I'm going to show you guys how to do something here. There's a couple options. You can have your answer as a decimal, or just because I want to try to get you guys ready for like the ACT and things like that, a lot of times on those tests, they ask you to leave your answer in terms of pi instead of getting it as a decimal, just because that way you don't have to take the time to put stuff in a calculator and you can do the problem faster, and they don't want you to have to rely on a calculator for those tests. So if we let this in terms of pi, well, 10 squared, remember PEMDAS, exponents before multiplication, 10 squared is 100. 100 times 2 is 200 pi for that part. All right, this part over here is 10 times 14, that's just 140. 140 times 2 is 280, which means we've got 200 pi plus another 280 pi. Or these are really just like terms. Do you notice if this said like 2x plus 3x, we make it 5x. We have 200 pi plus another 280 pi, then we've got 480 pi. So if you want to leave your answer in terms of pi, that's your answer. And we want to put it in square inches because we're talking surface area, right? How much it covers. And that would be an acceptable answer if it said leave it in terms of pi. Now, that's great because that's an exact answer. However, if you were actually building something and saying, how much material do I need to cover the outside of this cylinder? It's hard to go and buy 480 pi square inches of material. And so you'd want this as a decimal. And so getting this as a decimal, just plugging this into a calculator basically, and I use the pi button instead of using 3.14 for pi, just because it gives you a little bit more accuracy. It gives you 10 digits of pi instead of 2 digits of pi using 3.14. So if you use 3.14, you're going to get a number that's slightly different than this, but pretty close. This would be that same number, except now as a decimal rounded to 2 decimal places. So you could go through all this work and type in 480 times pi to get this, or you could put this entire equation in your calculator to get this, and that would work as well. So that's how we find the surface area of a prism and how we find the surface area of a cylinder. So there's a couple big formulas there that are helpful for this, and that's the way we're going to do this. Don't forget, we're talking area, so when we have our answers in the end, we want to put them as square inches.